Okay, good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Moore's Algebra 1 and 2 class. Today we're going to be talking about 4-2, solving systems of equations algebraically. Today specifically we're going to talk about substitution, because there are two other ways besides graphing to solve these systems. And one of them is by substitution, and the second one is called elimination. Sometimes they call the elimination the addition method, and when we learn it tomorrow, I'll show you why it's that. But today we're going to be talking about substitution. Now, when you think about substitution, think about the word substitute. Think about, you guys like sports, when they substitute one player for another. What does that literally mean? They replace one for the other, correct? They substitute. That's a substitute. When you have a substitute teacher, there's a different human inside of that room heading the class, correct? They have been replaced for that day or for whatever amount of time that it takes. So substitution, you're replacing something, okay? Think of that. You're replacing. The best way to learn this is just by doing it. What is the solution of the system of equations 3x plus 4y equals 12 and 2x plus y equals 10? Yes, you could graph this, and you can find the solution, especially for something like this. It's nice and easy. The numbers are going to be very pretty, but it's not efficient. It takes way too much time. So we're going to do it algebraically. Number one, choose an equation and solve the variable of your choice. Try to choose the easiest one to solve for. What does that mean? I'm going to look at both of these equations, all right? And in this first equation, yeah, it's easy to solve for x and easy to solve for y. However, when you look at this second equation, isn't it really easy to solve for y here? So me personally, I'm suggesting, look at the equations really quickly. Look at the variable that is easiest to solve for that variable. I don't care if it's x or y. It doesn't really matter, okay? Just solve for these ones. So, in my opinion, I think you guys agree, if we just solve for y here, we get y equals negative 2x plus 10, okay? So I already solved for one variable. We know what one variable already equals. Step 2, substitute the expression for the variable you just solved for in the other equation. Solve for the other variable. Okay, what does that mean? We just solved for y. We know what y equals. We know that y equals negative 2x plus 10. So I can take that y value and I can literally plug it in to the y of the other equation. Does that make sense before we do the math? What I'm doing here, what I'm substituting, what I'm replacing. I know that y equals negative 2x plus 10. Well, okay, then that means that this y here also equals negative 2x plus 10. So I'm going to go ahead and substitute. So I have 3x plus 4 times y, which we know y is negative 2x plus 10, equals 12. Does that make sense, guys? Because from here, it's Mickey Mouse. You guys can solve this in 2 seconds. But I want to make sure you guys can clearly understand and see, oh, okay, I got to replace that y value. How come? Because that's what y equals. Y is the same as y. So if I'm saying that y equals negative 2x plus 10, I can replace it into the y of the original equation, or of the other equation, rather. Does it make sense? All right. So let's go ahead and follow directions here. And it says here to solve for the other variable. So let's solve for x. We got 3x minus 8x plus 40 equals 12. I got negative 5x equals, sorry, I'm skipping steps here. Equals negative 28, right? So it's negative 28 divided by negative 5. So x is going to equal 5 and 3/5. So that's what my x value is. See, if we graph this, that would be kind of tough to estimate. Now we don't have to estimate. We can have exact answers. Does that make sense so far, everybody? Now, step 3. Substitute the expression for the variable you just solved for in the other equation. Solve for the other variable now. Now that you know what x is, can't I plug that into this equation here of y equals negative 2x plus 10 to find y? So I got y equals negative 2 times x. You know that you can't multiply mixed numbers, so I'm going to go ahead and turn that into, leave it as an improper fraction. So that's going to be 28 fifths plus 10. Do you understand what I did there, guys? I took my x value and I literally plugged it into the x value of the y equals equation. So now I got y equals negative 56 fifths plus 10. The denominator goes to 5, the numerator goes to 50. So y equals negative 6 fifths, which is negative 1 1/5. So my solution would be 5, comma 3/5, and 3/5, comma negative 1 1/5. And that is my solution. If I plugged it in, they both got to work. Yes, sir. The question was, after you find the x, you plug it into, this x right here. Because you want to find y. And didn't you already set it up for yourself that y equaled negative 2x plus 10? Great question. Great question. Yes, sir. Okay. Now what you did there is good, but it's way complicated. Because what he asked is, okay, I'm gonna erase this part here. What he asked is this. Can't I solve this equation for y and that equation for y and then set both of them equal to each other? Sure, of course. But that's a lot more work in my opinion. Because you got to solve this one for y and then set them equal. You're going to have more fraction work. But the answer is yes, you can. Yes. Yes, you can. Okay? The best way to do this and learn this is to practice. So let's move on. All right, let's solve these bad boys. Okay, in this case for A, I already have one of the variables solved for, don't I? So this is Mickey Mouse time. I love it when they give it to me like this. Sorry about that. Okay, so I already know what y equals, correct? Hello? So can I plug that value into that y too? So let's do it. So I've got 3x plus 5 times y, which is negative 2x plus 10, equals 8. All I did was substitute. I replaced. So now I've got 3x minus 10x plus 50 equals 8. And I've got here negative 7x plus 50 equals 8. Subtract 50 to both sides. Negative 7x equals negative 42. Divide by negative 7. X equals 6. Now that I know what x is, can't I plug that x value back into that x so I can solve for y? Do you guys see what I just did there? I need to make sure that you guys understand what I'm doing. Okay. So now let's solve for y. Y equals negative 2 times x, which is 6, plus 10. So y is going to equal negative 12 plus 10, which is negative 2. My solution, 6, comma, negative 2. That is the point that both of these lines intersect. Yes, sir. Okay, the question was, Mr. Morrow, can I plug this x? I'll do it in red. Can you plug this x into this and then solve for y? Yes. But again, why would you want to do that? That would just be more work for you. But the answer is yes. Absolutely. Does that make sense, gentlemen? That's a great question, son. Thank you. May I move on? Okay. For here, I don't have one of the variables already solved for. Which one, in your opinion, would you like to solve for first? The top y here? Yeah, I agree with you 100%. So I'm going to go over here, 2x minus y equals negative 15. I'm going to subtract 2x to both sides. Negative y equals negative 2x minus 15. Divide by negative 1. So y equals 2x plus 15. Now I know what one of my variables equals. Now I can plug that back into this second equation. So I got 4x plus 3 times y, which is 2x plus 15, equals 5. Is everyone with me so far? Okay. Now I've got 4x plus 6x plus 45 equals 5. 4x plus 6x is 10x. Subtract the 45 to both sides. That equals negative 40 divided by 10. X equals negative 4. Now that x equals negative 4, let's go ahead and take that negative 4 and plug it into that x. Why, Mr. Morrow? Because doesn't that tell you what y is straight up, nice and easy? Talk to me. You look confused. Talk to me. You good? You promise? Okay. So now I've got y equals 2 times negative 4 plus 15. So y equals negative 8 plus 15, which is 7. So my solution is an ordered pair, the x, comma, the y. That is the point on the graph where both lines intersect. Does that make sense, boys? Sorry about that. Does that make sense, my brothers? Okay, let's do it. Let's do it. Practice, practice, practice. I know it's crazy, but practice, practice, practice. All right. Who do you want to solve for here? Who do you think? You want to solve for the top one? Are you sure that this wouldn't be easier, guys? X equals negative 2y plus 13 over 2. I mean, I'm not trying to tell you what to do. I never said you had to isolate the y. I said isolate the easiest variable to solve for, whether it be the x or the y. Does that make sense, though, my friends? Yes. Okay, now that you know what x is, let's replace that x into there, right? Let's go ahead and do that. So I've got 2 times x, which is negative 2y plus 13 halves plus 3y equals 9. Take a breath. Look at what we did there. Does that make sense? All right, let's do the math. Let's distribute. So I've got negative 4y plus 13. Remember, I distributed here, guys. Plus 3y equals 9. Negative 4y plus 3y is negative y. Subtract the 13 to both sides. That's going to equal negative 4. Yep. Divide by negative 1. So y equals 4. Now let's take that y equals 4 and plug it into the y of the x equals equation. So x will equal negative 2 times 4, because that's my y, plus 13 halves. So that equals negative 8 plus 13 halves. Common denominator is 2. So this denominator of the 8 goes to a 2. That goes to a negative 16. So x equals negative 3 halves. That's what my x is. So what is my solution for this guy right here? Negative 3 halves, comma 4. Remember, my friends, it's always the x, comma, then the y. It's an ordered pair. Does that make sense, people? Now, I know that I'm doing the math here and you like to follow me, but the best way to do this is to try to do it on your own and then see if you came up with the same answer, right? Yes, sir. You could convert the negative 3 over 2 to negative 1 1/2 for sure. But I wouldn't do it until the end. It's easier to work with a fraction than a mixed number. Does that make sense, my friends? Promise? All right. I'll keep it up just in case anyone's still writing. And we'll do this next one in red. Okay, who do I want to solve for here? Who's the easiest to solve for? Yeah, the x. Let's add 3y to both sides. So I know that x will equal 3y plus 5. Nice. Now I can take that value of x and plug it into the x of the other equation. So I've got negative 2 times x, which is 3y plus 5, plus 6y equals 3. Let's go ahead and distribute. So I got negative 6y minus 10 plus 6y equals 3. Negative 6y plus 6y cancels. Wait a second. I got negative 10 equals 3? Is that a true statement? So whenever this happens to you, my friends, it's no solution, straight up. Now, what does that mean? If I solved both of these for y, what would we know about the slopes? They're parallel. They're equal slopes, right? Does that make sense, guys? So when you get a false statement, that would be an inconsistent system. No solution. Inconsistent. What would happen, do you think, if it was a true statement? It would be consistent, dependent, all real solutions, right? Infinitely many solutions. That makes sense, guys? All right. Let's continue. Okay, here, which variable do you think is easiest to solve for here? That's the y in the second one for sure. I'd add 3x to both sides. So I've got y equals 3x plus 2. I'm going to take that y value and plug it into this y of the first equation. So I've got 6x minus 2 times y, which is 3x plus 2 equals negative 4. So I've got 6x minus 4 equals negative 4. The 6x's cancel. Wait a second. Negative 4 equals negative 4. What do I do with that information? This is all real solutions, yeah. All real numbers. Or you can put infinitely many solutions. What type of a system is this? It's a consistent dependent. Very good. Very good. Knowledge is power, my friends. Good job. Yes, sir. Could you use the fancy all real numbers symbol? Yes, you may. Thank you for asking. Great job. But remember, I may say, what kind of a system is this? And you'd have to say consistent dependent, okay? In the one above, in the no solution one, this would be an inconsistent, right? Maybe I should learn how to spell. Inconsistent. Makes sense, right, guys? All right. Right quick. Let's just set this up. I may not have time to solve these, okay, guys? But let's set them up so you can see how easy this is. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music, books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? Well, let's think about this. 6 lessons it's gonna be $300, and and if you have 12 lessons, you have $480 for the cost. So, what kind of an equation here? What kind of a system do you think I can set up here? What do you think, guys? Let's think about it. I don't want to just give it away to you. Let's think about this. Yes, sir. Okay, yeah, we're going to have to set up in standard form, yeah, but what would the equation be? Yes. No, no, we're going to have a set of two systems here. Yes, sir.
X plus 6y equals 300. And the other one, x plus 12y equals 120.
I love it. X plus 6y equals 300, and x plus 12y equals 480. Now, this is beautiful except for one mistake most people do. Label. X is, I'm assuming, in your view, the one-time fee. And y is each lesson, the number of lessons. Does that make sense, guys? Promise? Okay? Because remember, the one-time fee here is pretty much the same. What's changing here? The number of lessons, right? So then you would go ahead and solve this using substitution. Perfect timing. Thank you very much. Have a great day. Take care. Bye-bye.